In the summer of 1944, a British Spitfire reconnaissance pilot returned from a routine photo mission over southern Germany. When intelligence analysts developed his film, they went silent. What appeared on those photographs didn't look like anything in their recognition manuals. It had no propeller. Its wings were swept. And according to the pilot's notes, it had pulled away from him effortlessly, at a speed no piston engine aircraft should have been able to reach. What they were looking at was the Messerschmitt Me-262, and it changed everything. By mid-1944, the Allied air campaign over Europe had reached a brutal rhythm. American B-17s and B-24s were flying in massive formations, absorbing catastrophic losses but pressing forward. The Luftwaffe, though weakened, was still dangerous. German fighter pilots were experienced, aggressive, and fighting over their own territory. But the numbers were turning against them. Fuel was scarce. Replacement pilots were under. The industrial base was being methodically destroyed from the air. Inside that desperate context, Germany's aviation engineers had been quietly working on something that, had the timing been different, could have rewritten the final chapter of the air war entirely. The Messerschmitt Me-262 was the world's first operational jet-powered fighter aircraft. Not experimental in the laboratory sense. Not a prototype that flew once and was forgotten. This machine actually entered combat. It flew against Allied bombers. It killed real crews. And it pushed speeds that no Allied pilot had ever faced in combat. When Allied intelligence pieced together what they were dealing with, the reaction wasn't just professional concern. It was something closer to controlled alarm. Because the Me-262 wasn't a desperate, last-minute invention. It had been in development since 1938, and the fact that it had taken this long to reach the battlefield was not a story of German failure. It was a story of catastrophic decision-making, political interference, and wasted opportunity that haunted Luftwaffe commanders for the rest of their lives. The origins of the Me-262 reach back to a Germany still technically at peace. In 1938, the Reich Air Ministry issued a specification for an aircraft powered by the new jet turbine engines being developed by BMW, Messerschmitt's design team. Led by chief designer Waldemar Voigt, under the direction of Willy Messerschmitt himself, began drawing up what would initially be called Project 1065. The concept was elegant in its ambition, a twin-engine jet fighter with a streamlined fuselage, a conventional tail, and a tricycle undercarriage, which was itself relatively novel for German aircraft at the time, but the design existed on paper long before the engines that would power it. This was the Me-262's first and most persistent problem. The airframe was ready before the propulsion technology could reliably support it. The Junkers Jumo 00 for turbojet, which would ultimately become the Me-262's engine of choice, was a revolutionary piece of engineering, and a deeply troubled one. Development was slow, failure rates were high, and the metallurgical demands of sustained high-temperature turbine operation pushed German manufacturing to its limits. Critical alloys, particularly nickel and chromium, were in short supply. Engineers at Junkers working under Anselm Franz were forced to improvise with substitute materials that compromised reliability. The early Jumo 00 for engines had a service life measured not in hundreds of hours, but often in tens. 20 hours of operation before overhaul was considered acceptable. Catastrophic failure, meaning compressor, blade separation, engine fire, or complete seizure, was a regular occurrence in testing. This is the backdrop against which the Me-262's first prototype flights took place. The first prototype, designated V1, made its maiden flight on April 18, 1941, at Augsburg-Hohnstein Airfield in Bavaria. But here is an irony that still astonishes aviation historians. That first flight was not powered by jet engines at all. The Jumo 4s weren't ready. So test pilot Fritz Wendel flew the aircraft with a single Junkers Jumo 210G piston engine mounted in the nose, a bizarre, ungainly configuration that technically made the V1's first flight not a jet flight at all, but a proof of the airframe's basic handling characteristics. Wendel was already one of Germany's most accomplished test pilots. He had set a world airspeed record in 1939 flying a specially modified Messerschmitt Bf 209. He understood speed. He understood aircraft at the edge of their performance envelope. And even in that hybrid piston-powered configuration, he could feel what the Me-262 airframe was capable of. The first genuine jet-powered flight came on March 25, 1942, again at Augsburg, with Wendel at the controls. The aircraft was fitted with two BMW 003 turbojets, and within minutes of takeoff, both engines flamed out. Wendel managed to land the aircraft on the piston engine, which had been retained as a precaution. It was a near disaster. The BMW 003 engines were not ready, and development shifted entirely to the Jumo 4. When the Jumo-powered flights finally began in earnest through late 1942 and into 1943, the results were extraordinary. The Me-262 in its intended configuration was faster than anything flying in operational service anywhere in the world. Measured performance figures from test flights at Lechfeld Airfield documented top speeds in excess of 850 kilometers per hour, approximately 530 miles per hour. For context, the best Allied piston fighters of the period were struggling to reach 700 kilometers per hour in level flight, under ideal conditions. The speed differential was not marginal. It was fundamental. Wendell and subsequent test pilots reported that the Me-262 felt unlike any aircraft they had flown. The absence of propeller torque made it unusually stable in straight flight. Acceleration, once the turbine spooled up, was smooth and relentless, in a way no piston engine could replicate. But the aircraft had vices, significant ones. The engines were slow to respond to throttle inputs. In combat, this mattered enormously. A pilot who pulled his throttles back too quickly risked compressor stall and flameout. A pilot who advanced them too rapidly invited the same. There was a careful, deliberate choreography required to manage the Jumo-4s safely. And in the chaos of aerial combat, that choreography could get a pilot killed. Early Me-262 pilots were explicitly warned, do not touch the throttles aggressively below 3,500 meters. This was not a suggestion. It was survival guidance. The aircraft's high-speed handling introduced another problem that German aerodynamicists were only beginning to understand in 1943 and 1944. Compressibility effects. As the Me-262 approached its maximum speed in a dive, the airflow over the swept wings began behaving in ways that classical aerodynamics couldn't fully predict. Control inputs became heavy, then reversed. Pilots who pushed too hard in a high-speed dive found the aircraft pitching nose down with increasing force, pulling toward the ground in what test pilots described as an almost irresistible tuck. Several Me-262s were lost in exactly this manner aircraft, entering steep dives from which recovery became geometrically impossible. Despite these dangers, Luftwaffe command was watching the test results with mounting intensity. General Adolf Galland, one of Germany's most celebrated fighter aces and the general of the fighter arm, flew the Me-262 in May 1943. His assessment was unambiguous. He described the experience of flying it as feeling as though angels were pushing. He immediately recognized that it represented Germany's best remaining hope for regaining air superiority. He lobbied hard and repeatedly for rapid production and deployment as a pure interceptor fighter. What followed was one of the most consequential and debated decisions of the entire air war. Adolf Hitler, increasingly obsessed with offensive retaliatory weapons following the Allied bombing campaign and the invasion of Italy, insisted that the Me-262 be developed and deployed primarily as a high-speed bomber, a so-called blitz. The idea was to use the aircraft's speed to penetrate Allied defenses and deliver bombs against the anticipated invasion of Western Europe. Galland and Messerschmitt both argued strenuously against this. The Me-262's bomb-carrying modifications reduced its performance, complicated its handling, and fundamentally compromised the very quality that made it threatening. Hitler's directive was not easily overridden. Months were lost reconfiguring aircraft for a bombing role. The airframe was poorly suited to serve. Production schedules were disrupted. Pilot training programs were reoriented, and all of this happened during the precise window, late 1943 through mid-1944, when the Allied strategic bombing campaign was at its most vulnerable, and when a properly deployed jet fighter force might have inflicted genuinely decisive losses on the bomber streams. By the time the Me-262 reached operational units, in meaningful numbers, it was summer 1944. Kommando Nowotny, an elite test and evaluation unit named after Austrian ace Walter Nowotny, began limited combat operations from Akma and Hessepi airfields in northern Germany in late 1944. The results confirmed what Galland had predicted. Against unescorted bombers, the Me-262 was lethal. It closed on B-17 formations. Its speed differentials, the bomber gunners had never trained against. Standard defensive fire solutions were useless when the attacking aircraft was traveling nearly 200 miles per hour, faster than anything the gunners had ever shot at. But the Me-262 was not invincible. Its vulnerability existed at the beginning and end of every flight on takeoff and landing, when the turbines were spooling and the aircraft was slow. Allied fighter commanders recognized this quickly. P-51 Mustangs and Tempests began patrolling the approaches to known Me-262 bases, waiting for the jets to enter their vulnerable phase. Allied pilots called this technique airfield strangling. Walter Nowotny himself was shot down and killed on November 8, 1944. Under circumstances that remain partially unclear, likely caught during the approach to Akmar after his engines were damaged in combat. The Me-262 was produced in relatively significant numbers by late-war German standards. Approximately 1,400 airframes were completed before the end of the war, though operational availability was always far below that figure due to fuel shortages, engine failures, spare parts scarcity, and Allied bombing of production facilities. The primary production variant, the Me-262A1A Schwalbe, carried four 30mm Mk102 cannons in the nose, a devastating armament capable of destroying a heavy bomber with a short burst. The A2A Sturmvogel retained a bombing capability at the cost of two forward cannons. Total Allied aircraft confirmed, destroyed by Me-262s in combat is historically documented at around 150, with additional probable kills. The number is modest relative to the aircraft's theoretical potential, a direct reflection of how late, how few, and how fuel-starved the deployment was. When Allied ground forces overran German airfields in the spring of 1945, they found Me-262s scattered across improvised forest dispersal sites, hidden beneath tree canopies, parked in camouflaged ravines. Aircraft that had never flown their final missions. Aircraft abandoned with full armaments still loaded. The British, Americans, and Soviets each captured examples and flew them extensively in post-war evaluation programs. American test pilots at Wright Field in Ohio flew captured Me-262s throughout 1945 and 1946. Their reports were frank. The aircraft was genuinely dangerous, genuinely fast, and genuinely limited by its engines' fragility and throttle sensitivity. The lessons absorbed from the Me-262 fed directly into every jet fighter development program of the early Cold War. The swept-wing geometry that Messerschmitt's engineers had chosen, partly for balance reasons related to the engine positioning, was studied intensively and influenced the design thinking that led to the Fatty-6 Sabre and the MiG-15. The aerodynamic problems encountered at high subsonic speeds informed a research that pushed aviation toward the sound barrier. What Allied intelligence had seen in those reconnaissance photographs in the summer of 1944 was not merely a new aircraft. It was the end of one era and the violent beginning of another. The piston engine fighter, which had defined aerial warfare since 1914, was finished. The Me-262 proved it. The tragedy, if one can call it that, in the context of a war Germany started and prosecuted with industrial brutality, was that the aircraft's potential was almost entirely squandered, not by the engineers, not by the test pilots who risked their lives in those fragile, temperamental machines over Bavarian test fields, but by the politics of a regime that could not separate technical reality from ideological fantasy, and by a leader who saw weapons of speed as weapons of vengeance rather than weapons of survival. By the time Germany understood what it had built, it was already too late to use it.